Morning guys, I'm just walking to the job. It's 6:30 in the morning. I like to get in early, get a quick coffee and then we can get set for the day. So let's jump into Starbucks and grab a quick one. Right, the first test I'm going to do is I'm going to test, as we pulled in new sub-mains, first thing I'm going to do is do an insulation resistance across these cables and the earth, which I've disconnected out of the bar because I've got my earths connected in a minute. So we're going to do an insulation resistance between the earth, the live and the neutral first. So at the minute I've got the breaker off, the main switch off and the earth disconnected. So let's go back downstairs and do the test. Right, there's no power onto this switch at the minute. I've whipped the cover off the main switch and I've got my tester out just with 2 probes at the minute. So we turn the tester on and we set it to insulation. What we're going to do is, we've got live, neutral and earth. What we're going to do is go between live and neutral, clear, live and earth, clear, neutral and earth is clear. Okay, so all I've done is add a little link into my live. I've connected the earth back in the bar and I've put the little link into there. So now we can do a reading R1 and R2. Right, I've now come back down to my tester. I've got my tester set to continuity. I've got the 2 leads there. You can now touch the leads, by the way, because we're now off insulation. You can see there my leads are giving me a reading of 0.83. If I then null those to 0, I now know any reading is a true reading between my cables and not the test leads. Okay, so same again, all we do is take the probes and go between the live and the earth, and that is giving us a reading of 0.04 ohms. So we can now record that on our test sheet. Remember to always remove your link here before you liven anything up. So I'm going to remove this link, then going to go back downstairs, energise this circuit, come up here and do some live readings at the fuse board. Show you this while I'm here. We had to wire an FP. This was an afterthought on the architect's behalf. An FP for supply down there. They're going to have a water tank here, and then you've got this spray nozzle that goes actually into the kitchen, and it just has a cold water feed there. Just has a spray nozzle that's actually facing into the living area. So obviously this is not linked to our fire alarm system. It has its own sprinkler head and a fire alarm built in, and obviously if it goes off on heat, then it will actually just dispense this whole water tank full of water into the living area. Right, we're now at the board. I've whipped the cover off. I've got the crock on the earth terminal. I've turned the switch on. Everything else is switched off. And I've got my crock on the neutral bar at the top there. I'm now just going to get my probe, stick it in the live terminal. I've got my tester set on loop to do an earth loop. We then just press the test button there. Tells you you've got your voltage and your hertz. It will then give you a reading in ohms, which is 0.18, which you can now record. Right, same again, we've got our leads set up on the same setup here. I've now got my tester set on PSC setting. You can see we've got live and earth. Live and neutral is correct. Voltage, we then press our test button and this will give us a reading of 1428, and we can then write 1.4 kA down on our test sheet. Okay, just a quick one. Once you've got power to the RCD, it will reset, so then you can check function of RCD just by pressing the test switch there. You can tick that off the list. Guys, I want to show you a ring final circuit continuity on a ring main that we've installed. So I've disconnected the 2 lives, the 2 neutrals and the 2 earths out of the fuse board. I've got my meter set to continuity with the 2 crocodile clips, and it's all nailed out and it's ready to go. So if I take one end of the ring and the other end of the ring, my crocodile clips, there we go, I've got a reading of 0.61 ohms. You can record that now. Do the same on the neutrals. It should be very identical to the lives. And as this is twin and earth, the CPC is smaller, so you'll get a higher reading. Put the two clocks on the two earths there. 0.82, so you can record all those readings now. And as we're working on this circuit anyway, I can now perform an R1, R2. So take your two lives and your two earths and cross them over effectively. So that brown will then go with that earth, and that brown will then go with that earth in the connector. And then grab your tester. So you want to then go around each socket on the circuit, plug your lead in, plug your two probes in that you get, leave the neutral out because you don't need it because you're just going between these two terminals. Set your tester up to measure, and then you should be able to switch the socket on and then get an R1, R2 each socket. So if you go around each socket, then you record your highest reading on your test sheet. Because I've now got power onto this circuit. This socket is just loose because the tiler is going to come and tile this backsplash, so I will turn this circuit off, but as I'm a competent person. So we're now going to do some earth loops at the socket. I've got my tester in on the loop setting. Socket is on, which then gives me the lights here. Literally you just press the button, go around all the sockets on the circuit, well I like to, and then record your highest reading, and then make a note of which socket gave you the highest reading, because then you can then perform your RCD test. I'll just show you that now. So if you change your tester to the RCD function and you want to change it to auto, you can then press this button and you can then go back to the fuse board, reset the RCD 4 times, and then when you come back all your readings will be recorded here. So let's try and do that now. You'll probably hear the RCD click off because I am in the utility, it's where the fuse board is. There we go, so it's tripped. 29 milliseconds. So if I now reset that. 54 milliseconds. Seven milliseconds. And 20 milliseconds. So what you want to do in your tester book or whatever, you'll have a ×1 value and a ×5. So you want to record the highest values there. So in this case, I'll be recording 54 20 milliseconds. Little test once you start getting the power on, make sure your smoke alarms are working. And that should be linking through now, all the other ones. There, we're in the kitchen. So there we go guys, that's just a shortened version of what we do as electricians as testing. Obviously it's quite a lot more in depth, but I've not explained the science behind stuff, I've literally just shown you the test that we perform and stuff. So if you found it interesting, give me a thumbs up. Any suggestions for me, give me a comment below, and I'll see you on the next one. Take care.